So interesting job here. We've got a Viessmann 300 and we've got a variable temperature mixing Divicon here and underfloor heating manifold here. So and then what we've got missing here is no hydraulic separation for the boiler. So when we turn the boiler on from cold, the valve in the mixer is fully open and the entire flow from the boiler is being pulled across into the mixing valve. Plus we've got a little bit of reverse circulation going on through here, and now I'm assuming we've got reverse circulation going on here. We might just have equilibrium, but it's more likely we've got reverse circulation. So that water's being drawn off into our underfloor heating, and the boiler is unable to see this circuit because there's no flow in it. So the load on the boiler will simply be the load of the underfloor. So we're going to have a really delayed heat up time for the radiator circuit. It's not until the underfloor actually starts to get up to temperature and starts to close the valve off, making less demand on the heating system, that we'll start to get flow through to the radiator circuit. Now if that was done with hydraulic separation and a separate pump here, we would have the correct flow rate going off around this circuit and the correct flow rate going off around this circuit, and the boiler would load match, so the boiler would put out the output required to satisfy both circuits. This is very similar to putting close coupled T's in front of a manifold, whereby we short circuit, hydraulically short circuit a system and cause it not to load match and not to have the correct flows in the radiator circuit. So it's not exactly the same, but it's very similar in effect. So no close coupled T's before underfloor heating manifolds, and we always need hydraulic separation for an underfloor heating system. Almost as a good sort of general rule, we need it, but if you get a bit more technical, there are situations when you can get away without it. But I personally would never install underfloor heating without hydraulic separation at my boiler. Right, what can we do about it? So in a video that Adam made for Heat Geek, he showed a system where he'd put a bypass in the system, and there was a mistake on the video showing it, explaining that it was on this side of the mixer, when in fact it was actually on this side, and that's actually in the Viessmann design guide. So if we had a bypass in here, similar to a close coupled T, but with a balancing valve on it, we could actually make sure that this manifold drew 2/3 of its water back on itself, and then only 1/3 of the water would be coming through this valve. Now that would balance with the flow from the boiler at delta T20, and the boiler would be able to see this circuit and run off to the radiator circuit. However, there's an extra problem in as much as there's a curve set for this circuit, a temperature curve for the weather comp, and the boiler can't really see that. There's no sensor on this side, so where the water's being drawn off on this side, that may end up with the wrong temperature on this side. Certainly going to end up with it not knowing that there's no flow in it if this is out of balance. But again, the best way to do this is hydraulic separation at the boiler, and allow the boiler to see what's going on both circuits, with the flow sensor for the common circuit and with the flow sensor for the variable temperature circuit. And the hydraulic balancing in effect would be done in the low loss header or in the hydraulic separation under the boiler, rather than having to do this bypass system on this side. Never on this side, don't care. No close coupled T's, no fixed flow bypasses ever on this side of a manifold, only ever on the other side, and best to do the hydraulic separation under the boiler. And so this one needs to be modified, needs to be corrected, so we get the correct flows in the correct places, and so the boiler can see what it's doing and control everything properly. And that's not a particularly big job to do. Set a close coupled T's under here, additional pump, and a pipe stat sensor similar to this one here, just plug straight into the boiler, and that's the job done, and that should render control. Customers have got very high curves set on this boiler, and I think that's as a result of this error. So what they're having to do, as I've said before, the cure for this problem is to run the boiler at high temperature and lose the efficiency. So this is being run on a curve of 2, and when I arrived, the gentleman was saying his wife's complaining about erratic temperature control in the house, and can't prove it yet, but I think it's to do with this lack of hydraulic balancing in the system. And once we've corrected that and got everything balanced up properly, we'll be able to see whether that's cured that problem or not. But for now, we know this isn't done to the Wiesmann design, doesn't follow the guidelines of the Wiesmann design guide, and we can see the problems, physically see them manifest, in much as that when we turn it on for heating, we're getting no flow to the radiators, as I say, until this has warmed up enough to shut the mixing valve. So it's not functioning correctly under high load conditions. So I hope that helps.